Okay, so in chapter 2, we're going to talk about matter, properties, and how they're going to change. This is our physical versus chemical changes, and let's start by talking about the properties that matter holds. So remember, matter is anything that has mass and takes up space. And let's start by talking about what a substance is. A substance is matter that is uniform or unchanging in composition. An example of this would be water, a good, healthy glass of H2O. It is simply made of hydrogen and oxygen molecules bound together in a bent molecular structure. It's completely uniform without. Water doesn't change its properties depending on what state it's in, but water is water. An example that wouldn't be that would be seawater. We start talking about seawater, it's got salt, it has sand, it has little particulates or what we could consider floaties in it. And so it's not really the same. They're very different. But when we start looking at pure substances, these could be any single element, such as tin, sulfur, even diamonds, which diamonds are completely made up of carbon. They're an allotrope of carbon. So technically a diamond is a compound. And then we got compounds. Sugar, which would be sucrose. Water, which is H2O. Salt. Those are all chemical compounds, but they're uniformly the same without. And even when we start talking about crystals, which all of your salts, by the way, that's all ionic compounds are salts. And then protein crystals, these are all in that same sphere. Any compound that has the same molecular structure or individual element can be a pure substance. When we start putting two pure substances together, that's when we get a mixture. So let's look at the physical properties first. The physical properties are characteristics that can be observed, they can be measured, they're not changing when we talk about a substance. And we have two types of physical properties. One type is called an extensive property, and the other is an intensive property. So let's look at an extensive. Now, X, as soon as you see that, external. An external property. These depend on the amount of the substance. This would be the length of the substance, the volume of the substance, the weight or mass. And then we have our intensive properties. These are internal properties. It is not dependent upon the amount of the substance you have. So an example would be density. So let's look at a few more intensive and extensive properties. So as we can see, our intensive is first. So this would be like our boiling point, our freezing point, our melting point, the normal temperature, luster, malleability, hardness, and we already said density. And then we have our extensive properties. These are your external. These ones can vary depending upon the amount. The size, the mass, the weight, the length, the height, the width, the volume, the area, all of that is externalized. Just think about like intensive properties being something like it's internal, such as your personality is internal. And extensive can change, such as my weight will change if I eat 5 pizzas at lunch. My weight is probably going to change. And if I don't eat lunch, my weight would also change. That would be something that's externally put into or added. And then we have a chemical property. Chemical properties are the ability for a substance to combine, change, whatever with other substances around them. This ability could be such as iron when it turns into rust. So when iron is put in the presence of oxygen, it will do something we call oxidize. It actually binds with oxygen to form iron oxide, which AKA is rust. But if I put that same piece of iron into a box full of nitrogen, nothing happens. Because nitrogen doesn't bind with iron like oxygen does because they have different properties. So oxygen will bind while nitrogen will not. And so let's look at a few of these chemical properties. toxicity, oxidation, combustion, stability, flammability, reactivity, possibility to make chemical bonds, enthalpy. All this stuff is chemical properties. Note, a lot of the things that you would see on the back is a warning sign on a material. They're chemical properties. So let's look at the states of matter. So we know the physical properties are going to be our extensive and intensive properties, and then we have our chemical properties, but this is all based on states of matter. So there are 4 states of matter, but we have 3 main states. We have solids, which have their own shape and volume. They're definite. We have liquids that will form to the shape of the container that they're put in, but they'll have a consistent volume. And then we have gases. Gases will have no specific shape or volume. They'll fill the entirety of the container. And I said there are 4 states of matter. So when we look at that, plasma is the 3rd state or 4th state of matter. So solids, note the particles. Our solids are really tightly bound together, and then our liquids will float through a container, and then our gases are even more spread out. So the close-knitness changes their states of matter. And we'll have our plasma, which is positive and negative signs. Plasma is really easy to make. We can actually make it by putting electricity through, something like a neon light. But I said we're going to deal with 3 states of matter because in chemistry, we are dealing with 3 states of matter. Plasma, though we can make it, it's a little harder for us to see that chemical change to them. So we're just going to deal with the 3 states of matter, solid, liquid, and gas. You'll notice one thing here. There's a temperature gauge on this side because if you're cooler, you're typically solid, and hotter is gases, and our middle is liquids. The other thing that will change this is pressure. If you notice, the increase in pressure we can increase heat and then prevent it from changing to a gas, such as when your mom or your grandma or your aunt or whoever uses a pressure cooker, they'll actually seal that and it doesn't turn into gas. So you can superheat a liquid higher in temperature than its normal boiling point. And we can use that by increasing pressure. Note, this is water. And so we know water has 0 degrees, 100 degrees for boiling points and freezing points. Carbon dioxide has a much lower freezing point and a much lower boiling point. So at room temperature, that is actually well past its boiling point. And so solid carbon dioxide won't hit a liquid state. It will just go straight to a gas. And so we call dry ice, which we use to pack and ship things in, it will turn straight to a gas. Okay, and that's our states of matter.